reactions are part of our day-to-day life, even though of us cannot perceive or understand them. Examples of these are the fermentation, combustion, and correction or oxidation of the metals. Others of great importance are those that occur in the organisms of all living beings, in order to provide the body with energy and then store and consume it. These kinds of reactions are indispensable for life. Now, what is the chemical reactions or how they are carried out? And in this, there are two types of reactions, which are exothermic and endothermic. At the moment, we will talk about the exothermic reactions. That will be those reactions where heat is released, and for this means that the energy of the molecules of the products EP is less than the energy of the molecules of reactions ER. In exothermic chemical reactions, heat is released, dH is negative and means that the energy of the products is less than the energy of the reagents, for example in the combustion of reactions. And while these are produced, we can observe that during chemical reactions energy absorptions or release may occur. This indicates that both reactants and products contain heat and in this characteristic of their mass. The heat content is a measure of energy that is accumulated by a substance during its formation.
Endothermic reactions. To understand the concept of endothermic reactions, we must review the words in Greek. Endo, which means inside, and therm, which means heat. In general, endothermic reactions absorb energy from the surrounding environment, usually in the form of heat, and is getting constantly absorbed. The energy absorbed provides action for the reaction to occur. These reactions lower the temperature of their surrounding area, thereby creating a cooling effect, like cooking food, melting an ice cube, or the ozone production in the atmosphere.
Our general objectives: to identify and improve our knowledge and understanding about exothermic and endothermic reactions. Specific objects: to improve our skills of teamwork and also to coexist with our classmates, to engage our relations as a group, share the acquired knowledge with our nearest classmates and teachers, to demonstrate these endothermic and exothermic reactions through an experimental application, knowing the uses and practical applications of endothermic and exothermic reactions on our daily lives, to promote and disseminate scientific knowledge, and to enable others to learn more about this interesting theme.
Hydrolysis, a very easy, economic and safety experiment. For this experiment, the electrolysis or hydrolysis will try to grow the molecules of the water. For this, we will need, of course, water, the still water that doesn't contain any type of ion. Then we will need sodium bicarbonate. We will need a topper, a battery. It will be of 4 volts or maybe 9. In this case, is of 9 volts. 2 clamps and 2 pieces of graphite that you could get from a pencil, and a spoon that we will use for mix the water with the sodium bicarbonate. For first, we will add the water to the topper.
After having mentioned the materials, our teammate begins to pour the water over the container where the reaction will take place.
Then, we take the 2 pieces of the graphite and put in each clamp. Now we have it. We connect the 2 clamps to the battery. And then we put the 2 electrodes of graphite in the water.
In a few seconds we will notice that nothing happens, and he will explain why.
As we could see, nothing is happening. Why? Because the water actually doesn't conduct the electricity. For the electricity gonna be conducted by the water, we will need the sodium bicarbonate. And we add it to the water. We mix it, and then we put the 2 electrodes of graphite in the water solution. As we can see, bubbles are being released from the 2 clamps. Depending on the positive or negative electrodes, the different oxygen and hydrogen will be attracted to the 2 different electrodes, and this is the hydrolysis. No? That's all.
The purpose of this experiment is to separate hydrogen and oxygen from the water using electricity. As we know, water is composed of 2 atoms of hydrogen and 1 of oxygen that are united by a covalent bond. This reaction between hydrogen and oxygen is known as a spontaneous reaction. That means that it happens naturally. This is because the energy of the final state is less than the energy of the initial state. That means that hydrogen and oxygen tend to get together, but we can separate them adding energy to the final state. To make this possible, we need to make an oxidation-reduction reaction. What are we going to do is to use a liquid that allows the pass of electricity, that when we put 2 electrodes, the electrolytes will travel to the negative and positive poles, completing the circuit. The ions of the liquids will release as solids, liquids or gases through the electrodes. In this case, hydrogen tends to receive electrons traveling to the negative pole, and the oxygen tends to give electrons traveling to the positive pole. H2 and O2 will be formed in each pole respectively. In the end of the experiment, we will see the liberation of these gases.
So we're going to do the exothermic reaction. So this is going to do of 1 tablespoon of bicarbonate sodium, like 1, and there's 1. Then we're going to put vinegar over the balloon, and the exothermic reaction is going to put it like a balloon, and it's going to inflate. But we're going to wait over 1 week, and the result is going to do like an exothermic reaction.
Okay, first here my friend is going to do an exothermic reaction. He first adds, what is that, bro? I think it's bicarbonate sodium, I don't know. Then he adds a little bit of vinegar. Yeah, I think that's vinegar. He adds both of them inside the balloon because he says it's going to expand. I don't know. He seems like he knows what he's doing. That's kinda cool, bro. But after adding those ingredients, let's see what happens to the balloon. As we can see, the balloon is going to expand a little bit. I don't know why that happens, but my teammate is going to explain that.
So this experiment is an exothermic reaction, which we can define as a chemical reaction that releases energy, which can be in heat or light. For this experiment, we will need a balloon, a small spoon, vinegar, sodium bicarbonate, a funnel. The steps are pretty simple. The first thing you will need to do is to put the balloon in the funnel, and after that you will need to add 2 small spoons of sodium bicarbonate. After that, what you need to do is to pour some vinegar inside of the funnel, so it will be in the balloon and it will start to inflate. But why does this happen? This is not only an exothermic reaction, but it's also an acid-base one. When you combine acid, which is the vinegar, with a base, the bicarbonate, a salt and a gas will be created, which is why the balloon inflates. After we mix them, energy will be created as heat. That's why the balloon inflates that fast. These kind of reactions are really common, since most of the energy we use is burning materials, which are known as fuels. So technically what happens here is that when we combine vinegar and carbonate, energy will be realized as heat. That's why the balloon gets inflated.
So, a chemical reaction is a process in which one or more substances called reactants are converted to one or more different substances, which are called products. Substances can be chemical or elemental compounds. We saw specific reactions in this experiment. Then we can conclude that the endothermic reactions are used to break bonds in reactants, and energy is released when new bonds form in products. In this reaction, it takes more energy to break the bonds in the reactant than it is released when new bonds form in the products, as we saw in the hydrolysis experiment. And in an exothermic reaction, chemical bonds are formed, so the energy is released into the environment instead of being absorbed. We can see this in the reaction of combustion of propane gas experiment.